And now it's technical time with UL.
Hello and welcome to Technical Time with UL, where we talk about the ongoings of the window and door industry and how we can enable safety and sustainability of your products. My name is Ryan Harper and I'm your host today. You may know UL for testing and certifying fire-safe products, systems and structures to withstand fire and other various testing programs. Joining me today, however, is Haya Sagrati, who is the manager of Toronto Laboratory Testing Services. And we're going to talk about how we provide a unique combination of services to assess and validate the design and performance of building envelope components, products, and systems. Thanks for joining me, Haya.
Thank you for inviting me, Ryan.
So Haya, let's, from a general overview perspective, how does UL help the building envelope industry?
Well, Ryan, through our services, we ensure building envelope products and systems meet regulatory demands and protect brand values. Manufacturers, consultants, architects, building owner, and regulatory authorities trust us for the knowledge and expertise we provide to the construction industry.
Right. Okay. We have got a really great team and a very experienced one at that. Many of them are recognized as industry leaders across the country. We operate, and these teams operate out of our centers of excellence in Toronto, Montreal, Chicago, and the UK. What services are we offering out of those laboratories?
Our labs offer a wide range of different testing services, including building envelope performance testing, fire testing, and also building forensic services and building system commissioning services. Depending on the services we require, we can test products and systems in the lab, or we can witness testing at the manufacturing facilities, or we can conduct on-site testing during and after installation. Our labs are capable of testing different products such as windows and doors, skylights, curtain walls, wall systems, full building envelope assemblies, and also guardrail systems.
Okay. When products are brought into UL for testing, what are they evaluated for?
Well, Ryan, our labs, which are recognized by many different industry organizations, provide performance testing to meet market regulatory and project specification requirements. We can evaluate the performance of the products based on air permeability, water permeability, water penetration resistance, wind load and structural resistance, thermal and condensation resistance, thermal and impact and pressure cycling, also thermal and hurricane resistance, and then also fire resistance and flame spread. To ensure products and systems meet many different industry standards such as NAFS, CSA, AMA, WDMA, NFRC, Miami-Dade, TAS, ICC, NFPA, UL, and ULC, or just to name a few of the standards we can test.
Well, that's a lot. Certainly. Well, again, thank you very much for your time today, giving a very brief overview of how we can help the industry. Thanks to you for joining us. If you'd like to learn more about UL services, please visit canada.ul.com/FenCan. That's FENCAN. Or you can email Haya directly at haya.sagrati, SOGHRATI @ul.com. Thanks again.
Thank you for having me.
Welcome to another Fenestration Canada podcast.
This podcast is a presentation of Quanex Building Products. For more than 30 years, Super Spacer Tri-Seal from Quanex Building Products has been the ideal warm edge spacer solution for commercial and architectural glass. With its unique triple seal design, Tri-Seal provides structural strength, durability, and outstanding thermal performance in the most demanding applications. Learn more at quanex.com. This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
Okay, so we're now live with Al Yagalis, our technical director. So this is Tech Talks, the last episode of the season. So just want to thank our sponsors. And on this, Al, up to you.
Great, thank you. Well, our guest today is Stephen Selkowitz. We're very pleased that we could have him with us. Welcome to Tech Talk, Steve.
Thank you. Pleased to be here.
Stephen Selkowitz is a building industry consultant and an affiliate at Lawrence Berkeley National Laboratory, where he recently retired after leading LBNL's building performance teams in research, development, and deployment of energy efficient building technologies and sustainable design practices. Steve is an internationally recognized expert on window technologies, window software tools, facade systems, smart glass and shading solutions, daylighting, and integrated building system solutions. That's a pretty broad sweep of areas that you've been involved with, Steve.
Yes, over 40 years, things add up over time.
They add up over time, don't they? Steve currently collaborates on research and demonstration programs with industry to develop and promote a new generation of highly insulating window systems and smart window solutions for buildings. So sounds like of those many technologies that you've been involved with, the one that we're interested in discussing with you today and learning more about from you today is the thin triples concept. And of course, this is only one of the many things that you've worked on over the years, but I'm curious, when did you first get the idea for the thin triple concept?
Well, we started, if I go back even a step before that, when I first started, the first thing we worked on was what eventually became low-E coatings and low-E glazings. So this was in the mid-70s into the early 80s. And the low-E work went rather well. And so by mid-80s, you had product in the market. You started to see some fairly important improvements in window systems. Then we started looking at what the next step would be. And at that point, we started looking at variants of triples and quads. And I think in the late 80s, we came up with this concept, now we're calling the thin triple, which is to add a centerpiece of glass that was thin and it wasn't necessarily part of the edge spacer. And we actually patented it we have a patent from 1991. The problem was, and it's a pretty serious problem, was the technology to make it work really wasn't there. So it sat on the shelf literally for 20 years. We took another look at it in the 80s. At that point, we had this thin glass from your cell phone or your laptop. And so the glass all of a sudden was available, but at a cost that was an order of magnitude more than made sense in the window market. And then we just took another look at it 3 or 4 years ago, and the cost of the glass and the cost of some of the krypton that was important for it had come way down, and the need had gone up from our point of view. So I think it was the confluence of the supply and demand side and interest that sort of raised up the level of activity. So we worked with through the U.S. Department of Energy, restarted a program there to look at this. And that program was done in the context of broader options. So we've been looking at vacuum insulated glass and looking at aerogel and looking at other options as well. I think these are all options that you covered in your NRCan project to sort of look at the future of glass in Canada as well.
Well, it's interesting that you mentioned that because our industry is these days very much aware of our government's commitment to tackling greenhouse gas emissions and trying to meet our Paris climate change accords. I think we struggle with that as most countries that have made commitments do. But one area in which we're trying to tackle, when I say we, I'm speaking of our government, is trying to tackle the greenhouse emissions problem is in the building sector through more energy efficient building codes and market transformation programs. And this topic is relevant in particular because we are now, it's been several years since Natural Resources Canada announced a market transformation roadmap for several technologies related to buildings, space heating, hot water heating, and windows. So here in the window industry, we have been given some fairly aggressive transformational goals for Canadian window industry, specifically aimed at the residential window sector, which probably accounts for the largest square footage of space heating and windows related energy performance in the country. So that process is underway. Actually, just recently, they've restarted a group of a consulting group, you might say, from industry called the Windows Experts Team, who are going to be, working with NRCan staff to see how we're making progress on this roadmap. And I note that one of the R&D objectives that had been identified in their 2018 plan mentioned thin triples as one of the high priority areas that should be investigated, to see whether they can whether this technology could be commercialized and deployed, in time to make an impact on the goals for 2030. So we're really happy to have you with us today to kind of update us on where thin triples are at today. And I'm very much looking forward to you sharing that with us. So please feel free to, share your screen. And
Okay.
While Steve is doing that, I just wanted to let our listeners know that we'll be able to take questions during Steve's presentation. Depending on the questions, we may answer them, in the course of the, presentation. But depending on the questions, we might also put some of them off until later, until Steve's done and have more of a discussion time. So we'll see what level of engagement we have there.
So do I have the right screen shared here?
Yes, you do. We're doing good, Steve.
Okay.
All the tech is working. So with that, I'll hand it over to you.
Okay, thanks. So I'll run through a number of slides here just to give you the sort of the framework, and I guess you can send your questions to Al, and we can do this interactively as needed, or we can come back later. So I'm starting off here showing the thin triple on the right and the thin quad on the left. I'm going to walk through a little bit of the logic we just went through, sort of starting with your interests and needs, and sort of update you on where we are at this point.
By the way, this is the first time I've seen the thin quad, so I'm interested that
okay.
You've got that on your on mind as well.
Yeah, and I've got that in there because you've got a 2030 goal that you're going to need something better than the, well, probably better than the thin triple. But anyway, I mean, the whole point of this is to throw this out and see what sticks, right? And I'm really interested in feedback from folks. Again, I should say that I attended two meetings in 2017 or 18 and or 18 in Ottawa and maybe some other place when you guys were working on your aspirational goals here. And it was a very interesting exercise. Some of you might recall that for the last 4 years, there's been, how should I put this politely, there's been less interest in energy and greenhouse gas in the US than in the past. That has changed and will change again on January 20th in a big way. So we're looking forward to that. But the research work, the underlying research work has kept going. So just restating your goals here, in particular, the 2025 and the 2030 goals of getting to about a U of 1.2 and then later a U of about 0.8. And you identified a variety of R&D emerging technologies that would be important and needed. And these are the same lists that we and everyone else that looks at the problem comes up with. Basically, you can tinker with gases and coatings and multiple layers. That's the second two here, the triples or quads or low-E coatings. And then you can vacuum, and you can also come up with a microporous material, an aerogel that is transparent and insulating. I've been working on all of these at Berkeley Labs since the 80s, at least. So none of these are new. That's not good or bad per se. It means, frankly, that they're tough problems. If they were easy problems, they would have been solved by now. There have been some vacuum glazing units in the market for a while. There have been new companies coming on board, probably beyond what we can talk about here, but there are price and manufacturing challenges. I don't see those. So the bottom line is, I don't see those as an early option that could be rapidly scaled in the time frame of 2025. If you go out to 2030, that probably isn't necessarily the same. And the same with aerogel. Aerogel's been kicked around for a long time. Again, from a research side, it's really neat stuff. From a practical side, at cost and practice and getting it out there at scale, it's been a challenge. So we fall back to multiple glazings then as an option for how to achieve the kind of numbers that you're talking about there. And then I would just say parenthetically, if you look at Northern Europe, they're largely triple glazed by codes and standards. Everyone has them. The policy has been consistent there for decades. The technology has been available. A triple is nothing magic about a normal triple. But at the same time, their typical window patterns, the tilt and turn window that's typical in Europe is a beefy sash and frame. And if you made a double before and you have a tilt and turn window, going from a double to a triple IGU is not all that complicated in the US anyway. And so I'm going to talk about my experience in the US, which I think is similar in Canada, although not identical. The classic window sash and frame was much thinner. You put it in a 2x4 inch stud wall for the last 100 years. Most of the windows in the US are sliders, so you have two panes of glass, two sash moving by each other. So the overall dimensions are very tight. And going from a double to a triple is technically straightforward, but from a business and practice point of view, a lot more complicated. So the bottom line is, excuse me, over the last 20 or 30 years, as codes and standards have changed and walls have gotten better insulating, windows haven't done much. So if you take a standard house now, a new house in the US, two-story, 2,000 square foot, IECC code compliant, windows make up maybe 7% of the area of the envelope, but about 48% of the heat loss. And that's because, by and large, the windows have improved somewhat since the 70s, but they made that one jump with low E. Wall insulation and attic insulation gets better and better and better all the time. Windows haven't kept up. So they've become a much bigger fraction of the heat loss. Now, going back to the, sorry, was there a question?
I think this is a very important slide because even though we talk a lot about window performance in our industry, I don't think I don't think our industry people and consumers actually appreciate the significance of these numbers, right? If indeed, half of the heat loss from the house is going out through the windows, that obviously from an engineering or scientific point of view, this is the first problem you want to tackle, right? And yet, by and large, I don't know how widely this is appreciated, that even, an upgrade such as low E coatings made a big difference to the performance of windows. And if you could go to triple pane units and several low E coatings, you would be doing even better. And potentially an improvement in the window might mean that you don't have to insulate the walls or the roof to the same degree as you would otherwise. I think this just kind of highlights, and I really hope that everyone that's hearing this program today, appreciates why windows are such a focus here in this market transformation program. They want to make the furnaces more efficient for space heating. They want to use less energy for hot water heating, try to recover energy where they can. But one of the top problems they're dealing with, that's on the heat generation. And the windows are the target to actually reduce the heat loss through windows significantly. And given that they're the biggest energy hole, they're obviously the number one target in that area.
Yeah, and the solution that sometimes come forward is, oh, windows are a problem. Let's have fewer windows, right? Let's make the window area smaller. This is a particular issue on the commercial building side. And if all you care about is minimizing energy loss and you're unwilling to do anything sensible like going to a better product, then that is the right answer. But that, of course, is a dead end as far as we're concerned. And on the positive side, the good news is there's opportunity. So in fact, if you look at the NFRC certified product directory, this is what you see in terms of double clear, double OE, and triple. So the axis here is on the top, not on the bottom, showing the U value of the window. And I've got the sorry about units here, I go back and forth, but the IP units on the bottom, BTUs per hour, and then I've got some metric equivalents roughly pasted on the top there. And the height of the bar here shows the number of window units that are certified. This happens to be vertical sliders and from 2015, but these things don't change that much over time. So you see this, well, what you see is you see the most products in the double OE, but you see quite a number of triples. This is deceiving in the following sense that this says this is what industry can make. Again, US industry, I know that some Canadian companies have NFRC data there also. But if you were to look at, and if you were to look at this, you'd say, gee, the triples are doing okay. We need to push a little bit harder, but they're in pretty good shape. But if you actually look at sales as opposed to what's listed in a directory, this is some data. Now, this is US data on sales. And you see the good news here from the mid 70s was that double pane replaced single. And then the good news also starting in the 80s was that double OE replaced double. So double OE is now 85, 90% of all the windows sold in the US. But if you look at triples, they're barely scraping along the bottom of the graph. They're 1.8% or something like that the last time someone did careful data in the US. Now, I'd be curious to know what the numbers are in Canada. I would guess they're higher, whether they're 10 to 20% or 30 to 40%. I mean, that would be interesting to know. But in the US anyway, they're barely at the bottom. And if you go to the industry and say why, it's not exactly rocket science. The kind of answers we get back on the Windows side and the builder side, they're too heavy, they're too wide. I mentioned the width issue before. They're too expensive. Part of the reason they're expensive is because they're not very common. If you have a specialty item or a special order item in business, usually there's a premium price above and beyond what it costs to make it. And if they're expensive, then you have a long ROI, long return on investment. That means when the code officials look at this as an option and they go out and price triples in the market, they say, oh my God, they're very expensive. They're not cost effective. They don't pay back. By code, they need to be cost effective so they aren't stuck into the code. So this is sort of the rationale for the thin triple in some sense, is that on the too heavy, too wide part of it here, if you could take the existing IGU and keep its weight and width and modify it so that you got more insulating value in that package, in that glass package, you would, and then of course, if you could do it at a reasonable price, you would solve the fundamental problems here. And yeah, and the note at the top there is that about 80% of US windows have a 20 millimeter IGU at the moment. So once again, if you were starting from scratch, if you're going to build a new window factory from scratch, you'd probably build it with a wider sash and frame and a wider IGU. But given the real world where you've got an existing infrastructure and investment of hundreds of millions of dollars probably in making windows different ways, the question is, can you change the way from a window manufacturer point of view, can you upgrade the IGU so that the pathway to get to a better window value is rather low? And if you think about it for a moment, that's exactly what was done in the 80s and 90s with the low E. The low E IGU looked and felt the same as the normal double glazed IGU. It just had a coating and a gas in it. That, by the way, is its own problem. If you can't see the difference, how do you know that it works? And this was the origin of NFRC in the US and equivalent kinds of standards and so on in Canada. So that's a whole nother issue. The other thing I just want to flag here for a moment is, I'm trying to be clear about this, but there's an IGU, there are thermal properties of the IGU, the U value of the IGU, then there's the U value of the window. And there are important differences there. I've tried to either have show here UW as the window U value, and then there's a UCOG center of glass. So if we now take...
Before you go on, Steve, sure. We had a couple questions from the 2 slides back where we showed the heat flow from the windows in the house.
Yeah, we actually have more. Yeah, we have like 4 questions about that slide.
Okay. So first question here from... are you going to doing the question, Steph, or shall I?
I can start with the one from the chat because I'm not sure you see them. So Thomas is asking, the NRCan report only showed the 35% heat loss through windows. Can we now say 48%? So that's the first question.
So this is for a specific, I could dig up the reference for you, but this is a house that meets the IECC 2015 code. I'm guessing here that your newest codes in Canada may be tighter than that. But I mean, it's an exercise you can do yourself. I mean, you could take and frankly, if it wasn't a 2,000 square foot 2-story house, if it was a 1,600 square foot 1-story house, the numbers might be different. But the bottom line is whether it's 35% or 40 or 55%. I mean, the windows are going to be a disproportionate fraction of the heat loss, and that is simply because the insulating value of the window is what, 1/5 or so of the insulating values of walls and roofs and ceilings and so on.
Okay.
So basically, this is a fairly typical American house built to the 2015 International Energy Code in the U.S. It's not necessarily representative of Canada. The other question was, what was the 7% referring to versus the 48%? So it's possible the questioner, wasn't able to study the slide long enough. So
so it's the area. If you take the total envelope area, the walls and the roof areas, windows are about 7% in this code compliant house. That's usually it's expressed as a window to floor area. Well, it varies. Sometimes it's window to floor, or if it's probably 15 or 20% of the wall area. But then when you put in the roof and maybe I don't know how basements are considered here, it becomes a smaller area.
So then in answer to Abdul's question, the 7% here is that the windows represent 7% of the above ground enclosure of the building. Would that be correct?
That's right. I think that's that's the right way of putting it. Yes.
Yeah. And so we have, 7% of the above ground enclosure, which includes the roof and the walls, but in this case is responsible for 48% of the heat loss. So that's just to clarify the question from Kareem. He says that's clear now. And then another question about the 48% being unchanged. Terry was asking, but I'm not sure what he means by is 48% unchanged. But maybe it's been clarified that this was maybe clarifying the house in the States built to a certain version of the code.
I think if you read the first, there's another question before about 1980, so that might be.
Okay. So the previous question from Terry was wondering what would the comparison be from 1980 to today in terms of the relative, heat loss, proportion of heat loss through windows relative to the enclosure.
Yeah. So I don't know that off the top of my head, but you could calculate it. Two things would change. I mean, the window in 1980 probably would have been a normal double glazed window, not double OE. So it would be worse. It'd be 30% worse than today. But the wall and roof insulation in 1980 would also be worse than today. And so, it's a calculation. You could go back and look at a typical house then and look at those. I mean, these are simply UA calcs, right? The U value of the envelope element times its area. And you could quickly do that for any existing or new house that you wanted to. And again, it will vary with single story versus 2-story. It'll vary, it'll vary with all these parameters with the percentage of wall area. The point is in the end that the windows are a proportionately larger impact on energy loss than they are on area. And again, whether it's 48% or 38 or 58, that will vary. And it will vary with time, as the last questioner just pointed out.
Yeah, thanks. So appreciate that. So we can continue then. Yeah.
Okay, so just to be clear what we're talking about here, you take a normal double glazed window on the left with one low-E coating, usually in the number 2 surface, and you now add what you do 3 things. You put a third piece of glass in there in the center. Notice that this is not a double spacer. This is just sort of sitting inside the single spacer here. You add a second low E coating on the number 5 surface. And then because we haven't changed the dimensions, the air cavities are now more like 8 millimeters rather than 12 or 15. And then our argon isn't optimal. You want to go to krypton for the thinner air gaps. So we've made 3 changes. We've added a coating, we've added a piece of glass, and we've changed argon to krypton. And when you do that, you basically double the insulating value of that center of glass. Now here I'm showing center of glass from about 1.4 to about 0.7. I should mention, if you go back the other way, that the double glazed without low E and gas fill is about 2.8. So I wrote a paper a couple years ago about, you know, how in the computing world they talk about doubling performance every X years. Well, we doubled the performance from normal double to double OE, and now we're doubling it again from double OE to the thin triple. So and then I mentioned this before. We've been thinking about this for a long time. Here's the 1991 patent. Notice the patent showed that center glass is kind of in a clip, just sitting in a clip in the middle of the window. There's a variety of different ways of dealing with that. I'll come back to that later. And now to get slightly more technical, just to give you a flavor of what matters and how here. And I'll bring up the quad here as well. So this is a little busy, but let me see if I can walk you through it quickly. The purple and the red are double glazed. Okay, so we're looking at the U value on the vertical scale. I've got my metric units out here on the left, and then the old IP units sort of near the axis. And on the lower axis, I've got the width of the IGU. So I've got this, the first line is at almost a 3/4 inch IGU, and the second one is like in 1.2 inches, or 17 millimeter IGU and a 30 millimeter IGU. So I've just taken those 2 points to talk about. If we first start with the thin IGU, the purple up there is just normal double OE, and then the red is double OE with a surface 4 low E. So most of you probably know that if you've been sitting with a double OE and you want to get an increment in U value, you can put a second low E on the inner glass surface facing the room. We could probably spend a half an hour talking about all the details of that, but just for the sake of for purposes here, that will improve your U value. It drops the temperature of the glass and has some condensation issues, but that's another discussion. So we're showing here, the other thing, I've got double lines. I've got a solid line and a dotted line. And the solid line is argon fill and the dotted line is krypton fill. So when you've got one cavity, which is about ½ inch cavity here, so this is a 3/4 inch IGU. Sorry, I will flip back to inches. It's a 17 millimeter IGU with 2 pieces of glass and maybe a 12 millimeter air gap. The choice of gas doesn't matter that much. You only get a tiny change between the solid line and the dotted line on both the normal double and the double with surface 4 low E. And if you make the unit even wider, going to the right, not much changes. But now look at the triple. That's the green one here. Because the triple gaps are going to be much smaller now, the difference between argon and krypton is the top of the green to the bottom of the green, and it's a big difference. So adding krypton brings you all the way down to about 0.7. Can you see my moving arrow here?
Yes, we can.
Okay, great. So this is down to about 0.7. If I said I don't want to bother with krypton, I'm going to stick with argon, I'd be all the way up here at 1.2. So because the gap is thin, the gas makes a difference. Now what's interesting is, I go to the right here and I get a wider and wider IGU. I'm going to stick with the triple here. Notice by the time I get to this, well, and I got to do a quick conversion here. Time I get to this 32 or 30 to 40 millimeter, sorry, IGU here, the krypton, this is at the right-hand side, because the gaps are wide now, it doesn't matter whether I use krypton or argon. So krypton and argon matter a lot, or that difference matters a lot when you have a thin gap. It doesn't matter much here. But now in the blue, I've added a 4th layer. I've got a quad, and the blue piece here is now a quad. So you notice with a quad, if I'm at about 30 millimeters here, I can get down to a U value of about 0.4. This is again center glass, and I could go even a tiny bit lower if I make it even wider. If I stick with argon, if I make it really wide and go with argon, I can still get a pretty decent, like a 0.7, 0.6 U value. So the triple and the quad give you some, between the use of 2 Lowy coatings and the gas choice and the gap dimension, you can get out to your 2030 target aspirational goal here for an IGU that would fit, this 0.4 IGU will be a nice piece of a 0.8 U value window. So now this raises the question of, I've got an IGU, but I've got other things going on. I've got an edge of glass that I haven't talked about. I've got a sash and frame. So we just take a quick look at that. So here I'm looking at U value on the vertical scale. Sorry, I didn't add the metric stuff here, but this is really just to show you about what matters and what doesn't. I don't care about the numbers as much here. I'm looking at 3 different issues: frame cavity, glass coating, and spacer. Let's take the easy one, glass coating in the middle. Those lines are almost horizontal. The types of different Lowy coatings make a little bit of a difference, but not much. Oh, I should also mention, I've got 2 different windows here now. The top one, the dotted line window in each case, is a double hung. So I've got a lot of sash and frame per overall window area. The bottom one is a fixed window. So basically, this is telling you that between the dotted line and the solid line in each of these 3 cases is telling you how important the sash and frame are. This also says that however good you do with the glass, you need to pay attention to the sash and frame. Now, to get to 1.2, you can pretty much do it keeping your existing sash and frame. If you're going to go to your 2030 targets, you're going to have to change the sash and frame as well. And you
that is a very important point, Steve. And it's something I've noticed as well when studying window designs and U values, is that, a triple pane window in one of today's existing frame designs gets you to that 1.2 level, gets you to that Energy Star level in Canada. Mm-hmm. But the next step, to go from that 1.2 down in the direction of 0.8, at least with triple glazing, that's not enough to get you much farther than, down to maybe 1.0 with a better frame design. But really from the 1.2 Energy Star level we have today to 0.8, we're talking about, you have to now tackle the design of the frame to get that improvement down towards that aspirational goal. Yep. So essentially, some companies I've noticed have designed window systems where they just have 2 sizes of glazing bead. And so they can sell you a double or a triple with very small incremental cost, because the triple is not a different frame, it's the same frame. Mm-hmm. And they can get right into that Energy Star level of performance with an existing frame. But the challenge to go beyond that level is down to frame design, for exactly the reasons you mentioned, is that the dotted line represents how much greater the heat loss is when you've got essentially 2 frames. You've got the perimeter window frame and you've got the sash frame that holds the glass. And if you look at really efficient window designs, and this is where it's sometimes interesting to take a look at the most energy efficient window designs you can see in a Passive House database. The most energy efficient designs shrink the frame down to where even in an operable window, the sash portion is no higher than the fixed frame portion. And so you maximize the glass area. You essentially have the same size glass in the operable as you do in the fixed. And this is, in a way, it's a simple concept, right? Because the frame is, what you're showing us here is the frame isn't as efficient as the glass, and therefore minimizing the frame is a strategy for designing a more efficient window. But I think these graphs really show the difference, because if you can actually get your window frame shrunk down for the operable towards the amount of a fixed window, you are now actually significantly improving the performance of that window by just letting glass do more of the work and kind of hide the frame.
Yeah, so here are 2 new challenges that come out of that. One is, go back to your designers, to the architect or the builder. If you've got, so I'm sitting in a room now, I've got 5 windows to my right here. casement windows, but 3 of them are fixed and 2 of them are operable. So I want ventilation, I want operable windows, but they don't all need to be operable. So thinking about what part of the fenestration needs to be openable, and we want fresh air, at least when there's not fires in California, we want fresh air, but we don't need it all the time. Now, the other issue, which is interesting, is I should have mentioned, all of these U value numbers here are based on NFRC calcs. And NFRC takes a standard size window. If you want, whatever, 20 to 30 meters of window in your house, and you have a choice of having many small windows or a smaller number of large windows, just in terms of what Al was just talking about, the smaller number of large windows by definition will have more glass and less sash. And therefore the actual U value will be quite a bit, or might be quite a bit lower. But the NFRC U value is going to be the same, right? Because it's not generally size dependent. So this is an interesting issue, is that by the time you get to 2030, maybe what you want to do on the code side is provide an option, be a little extra work, but provide an option that would allow the window makers to calculate the size dependent U value of the product, as opposed to taking a simple standardized one. And that's extra work, but if you're doing it to get extra credit, it's kind of like a performance-based code. It might make some sense. So that's something to think about.
Well, this is actually something that the British Columbia Step Code has introduced,
okay,
where for the higher steps of performance, you need a performance model, an energy model for each home. And when those calculations are run, if you input the NFRC U value into the HOT 2000 program, and you choose the correct option, it will scale those values to the actual sizes of the window,
mm-hmm,
and take it into account their orientation in the home with respect to the cardinal points of the compass, so as to capture the actual size performance. And there's a performance path will be introduced into the national code as well. So as we approach 2030, building codes will be taking account of that actual size performance of windows,
okay,
to a degree that isn't the case in US codes today. And it's not the case in the base code yet in Canada either.
yeah. And you raised another point that we won't get into, and that's orientation and solar gain, and that gets you into ER, and that's probably another whole topic. So this is a good lead into my next slide. So what's happened in California, we're actually seeing some action in thin triples in California. Say, why the hell would you do this in California? It's warm and all that good stuff. But here's what happened. The latest version of the code mandated a change on the mandatory code side for the insulating value of the wall, but didn't do anything to speak of the windows. So the builder is now required to invest an extra $3,000 per house to make a higher insulating wall, either going from 2x4 wood construction to 2x6 or adding foam insulation on the outside. That costs about $3,000 bucks. But if you're now a builder and you go to the trade-off, the California code trade-off option, you can plug your numbers into a computer program. And it turns out that if you go to triple glazing, if you go to a 1.2 U value window, you don't need to use that wall insulation package. So if you're a builder, instead of spending $3,000 on your wall insulation package, you can spend it on the windows. So if this house has about 500 square feet of windows, this is your 2,000 square foot house, 20% glass area, I've now got $6 a square foot. So as a builder, if I can buy a triple glazed window at an incremental cost of $6 a square foot, I'm going to end up with a cheaper first cost for my house. I'm not talking about energy savings now. This is first cost. I can end up with a cheaper first cost than by going to the wall package. And on top of that, if I do the whole wall thing, like with external foam, I've got to train my construction crew to figure it out. If I'm building houses to the lot line, I've now got extra dimensions for wider walls. I've got a whole host of issues that I've just avoided. I always had windows in my house. I'm putting in a new window now. The window's pretty much the same weight because it's in triple as it used to be. So there's no other change other than the fact that I'm paying the window company a bit more. So this has actually triggered a bunch of interest. And this is a sheet. This sheet here is from a utility in the area where I live here, where they were offering essentially a free upgrade to a thin triple to kind of get people excited and interested, get the manufacturers going. And at least a couple of manufacturers in California are starting to supply this market now. And this is a model that we're looking at for other parts of the US as well, getting a utility involved, getting some code compliance kinds of things going here as well. And then the practical problem, though, is what we ran into here quickly was we got a builder say, okay, great, I want to do this. And they said, where can I buy these windows? And now all of a sudden we shift back to the supply side and can you make them? And so I don't want to go into, great detail here, but in the long run, we'd like to, in order to keep the costs down, you might want to go to automated manufacturing. In general, we've talked to all the folks that make these equipment lines, and there's no reason in principle why they can't be adapted to do a thin triple. There's some technical details we could talk about if there's more time. Let me go through a couple of other things. The other question is, well, is thin glass available? When we started out here, we were talking about like 0.5 millimeter, 1 millimeter glass. Those are available from the companies I show on the right here, coming out of the display world. But the first product that was developed for this California market was actually shown here in green, a triple with 2.3, 1.6 millimeter, and 2.3 as the IGU package. And that 1.6 millimeter, which is the thin version now, is available from 3 or 4 large float companies. So this is widely available in the US at quite reasonable cost. The cost on the thinner glass was up in this $5 to $10 per meter squared. The cost for 1.6 is lower than that. So the answer is yes, glass is available. Then there's a question of, well, can you handle it? Well, again, the answer is yes. And I want to point out as a side note here, the flat screen TV industry sells about 40 million windows a year in the US. The average size is now about 8 square feet. In the US, we buy about 50 million residential windows a year. Their average size is 10 to 12 square feet. So as a takeaway here, almost as much thin glass goes into American homes each year as goes into windows. And that's not
in other words,
true.
it goes into American homes through TV sets.
Through TV sets, right. So
Right.
My point is, there's a manufacturing infrastructure out there that cuts it, cleans it, handles it, transports it. And these days, you can buy a giant TV for like $700, and you can easily spend $700 on the whole window. So lots of details here, but the point is that this is not esoteric stuff that doesn't exist in volume in different places. The problem, frankly, is the window industry doesn't have that capability, but they can beg, borrow, steal, or lease it from a bunch of companies that already make it. So I'm trying to distinguish here between problems that are fundamental research that might take years of R&D, and there are some like aerogel, and things that are largely almost available but need more hands-on R&D by the companies that want to get engaged. And I'm arguing here that the challenges for thin triples, and there are challenges, are of the latter kind. They're not the fundamental kind. So the other big issue or the other challenge is spacers. Again, you can always make a conventional triple, nothing wrong with that. And that's what the first on the upper right here, you see there's a conventional triple before putting the secondary seal on with a thin glass in the middle. And some of the partners we've worked with have made 1.5 by 3 meter units here. But there's a whole bunch of product out there, either real product or patent literature of people that have been making or trying to make or have designs for single spacers that can accommodate a center glass. So again, lots of room for innovation, for more innovation here, but there's product and technology available in the market now for that. There's 1 or 2 other things worth mentioning. Safety glazing. The code requires for patio doors and windows below a certain height in the wall, safety glass that will shatter in an appropriate way when it breaks. You can't do that with glass that's thinner than about 0.2 millimeters. So you either need to use maybe thicker glass or put a film on the glass. There's some issues here that are being looked at. About 15 to 20% of the glass door or the glass window area in the US is of this type, would sort of deal with safety glazing. So that's a flag. In terms of, if you're looking at the U value of a package of windows for a home, if you do an average U value, then your safety glaze windows might be not quite as good as your triples, and the average might turn out to be okay. So there are issues that we're working, and one of the ways we're sort of exposing these issues and working with them is getting involved with demonstration projects. So we've got a bunch of demonstrations going on in the US. The Pacific Northwest Lab is doing some with some DOE funding around the US, in the mid part of the US and the eastern part. We just are launching, we meaning Lawrence Berkeley Lab here, a new program in California. It's a 3-year, $3 million program in multifamily housing, in retrofits, actually. We've got a huge opportunity with retrofit. And that's trying to stimulate on the manufacturing side what's going on. In the Northwest Energy Efficiency Alliance, so this is a group that works up in Oregon, Washington, Montana, and Idaho, is looking at a utility rebate program or some type of incentive program that would incentivize this and push it forward. And we're kind of kicking around an idea of having what we're loosely calling now a partnership for advanced windows, where organizations, and we hope that some north of the border here, would be engaged and be interested in sharing information, sharing what works on both on the technology side, but also on the program side. A lot of this has to do with program. And let me just—
Steve, just a question.
Yeah.
So
Sure.
all of these research projects you've listed here are they focused on thin triples, or are they broader energy programs that are where thin triples participate, but that's not the focus? Or is the focus of these on thin triples?
Yeah, the two that I've listed there, the California National, those are both DOE and CEC funded. Those are both focused on thin triple. And the reason it's been interesting. I mean, the reason is because we want to sort of push and pull the technology into the market and see whether it would really fly. Now, the Partnership for Advanced Windows, I mean, you've raised a really interesting point. Although we'd love to see all this work, we're technology agnostic. And so I want a 1.2 U-value window. I don't really care how you get it, as long as it meets all the requirements that it needs to meet. So the Partnership for Advanced Windows, we're thinking will be agnostic with respect to how you achieve it. But the programs that we're pushing, in particular, like this NIA program here, we're pushing on the thin triple side because we think that's the fastest way, the fastest, maybe cheapest, but fastest way to break into the market and get this 1.2 product widely available. We're also hoping in the long run that if it gets out there as a triple, maybe that'll stimulate investment in vacuum insulating glass as well and other options. What we'd like there to be in the long run is multiple options that meet multiple criteria. The reason we're emphasizing thin triple is because, again, we think that's the fast way to get there. You don't need to build a massive new manufacturing infrastructure to get there. All the pieces and parts exist. They just need to be sort of tapped into. And then finally, let me just say that we mentioned the quad here before. I talked about this, that in some ways the thin triple is a platform to get you even further to the thin quad, which is exciting. The other thing is that this isn't as much of interest for you guys as us probably, but you can get a wide range of solar gain here because you're using 2 low-E coatings. You can do that now. I'm going to come back to thermal comfort in a moment. Dealing with codes and standards, big deal. We've talked about that a couple times. A big issue in the US, I think maybe in Canada too, is decarbonization. In the US, when much of the heating is gas-based, if you're going to decarbonize and shift to the grid, all of a sudden you've got all these poorly insulated homes with lousy windows that are going to have winter morning peaks, and classically the utilities had summer afternoon peaks. That's going to be a big issue. And so there could be a reason to make a public investment, low-cost loans, other things like that, to promote better windows, both in retrofit and new construction. Energy Star, you guys have already done the Energy Star thing. I keep referring to what you've done as a model for what I'd like to see in the US. I keep hassling our friends at EPA in the US to follow the Canadian model and shift to a 1.2 kind of number. We'll see how that plays out. And I want to just flag the idea that there's opportunities on the commercial building side and for secondary glazing. But let me just show as the last 2 slides here. I mentioned comfort. One of the ways we're trying to help window companies sell a better window generally, this is just U-value based, but this is a calculation that shows spatially and graphically for across the top here, from small windows to big windows, and then 5 different window designs. how much of the space in the room is on the left here, lower left, this is a living room, how much of the space of the room is thermally comfortable? And there's a percent dissatisfied. Whoa, what just happened there? Are you guys still seeing? Okay, sorry.
Yes.
Okay, so what you're seeing here, if it's light color, you're comfortable. If it's dark, you're not comfortable. And the triple here, it could be any triple, frankly, as long as it has a 1.2 U value, is basically comfortable throughout the space. Notice that's not true with a Surface 4 low E. It's not true with a normal double. This is a Minnesota design day, so it's cold outside, but probably typical of much of Canada. So we're basically trying to go beyond the energy savings and pitch the comfort pitch here. And then finally, in terms of comfort as well, the idea of secondary glazings. This is a company in the US. It's developed an add-on window. This is a thin glass element with a thin piece of plastic laminated to it. And a person of not a weightlifter can carry a relatively large unit with ease here. She's even smiling because it's a thin glass unit. You can put this on you can put a low E coated version of this. You can do a standard version, but there's a huge opportunity in retrofit. If we're going to decarbonize the US and Canada, we're going to have to look at all those existing buildings that need to be improved. So there's a bunch of other interesting opportunities, but that's sort of maybe another topic as well.
So is this something that's mounted from the inside of the window or
yes.
from the outside?
Yeah. This would be mounted from the inside.
Okay.
There's a couple products like this in the market now. They tend to be normal glazing, and so they're rather heavy. Some of them are double glazed. I mean, there's a variety of different options. We've done some field testing. They work fine. They also reduce infiltration. So there's some opportunities here as well. And opportunities on the residential side as well. So have we stimulated some more questions or comments here?
Let's open it up for questions from those who are viewing. We don't have any questions open at the moment.
Did we mention what Dave mentioned here? I just don't know if we...
Well, Dave had a comment that we were talking about that at the Window Experts team, but I'm not sure exactly what aspect of this conversation he was referring to. So if Dave would like to clarify that or repeat it.
Okay, I'll let you know.
Yeah. So while we're waiting for that, so it's quite exciting. It sounds like what's happening in California. What the California code has done is it's recognized that the windows are losing so much heat that upgrading to triple pane windows is as effective or more effective than adding exterior insulation or having a thicker wall with more insulation over the entire house. And this is the kind of thing that the Canadian HOT 2000 performance models are showing, where you are trying to model the thermal impact of certain energy efficiency measures. What's the overall impact on the house? And when you do that thermal modeling, the value of high performance windows really begins to show up. In some cases, they start becoming the most cost-effective path for the builder. So under the current code, there's no value to a triple pane window, let's say, to a builder. It just costs more money. And yes, the homeowners will be more comfortable, but they're not going to get that, nobody's going to pay more for those better windows unless they can feel the difference. And even if they can feel the difference, they still might not want to pay for it if it costs more money. But when the builder realizes that the cheapest way to build at some code level that's beyond today's code level, that it's actually cheaper to put that money into the window and possibly into the space heating system or other things, the value of high performance windows really shows up. And one of the things I noticed in the public review of changes to the national code, where they were advocating a kind of a baby step in that direction, is they proposed to award points for different energy efficient measures that a builder could take. So the industry wasn't ready for performance modeling of every house using software. But what they did is they gave the builder a menu of choices. You could add insulation to the walls, to below grade foundations, to the roof. You could upgrade your, make changes to your mechanical system. And for every one of these measures, they accorded a number of points.
Mhm.
But if you were in, one of the colder parts of Canada, not just the most southernmost parts, not just southern Ontario and southern BC, you could get 7 of the 10 points you needed with Windows at 1.2. And again, that's not in the code yet, but this was a proposed change. We're expecting it in the 2020 code. And it's at that point that I think the building industry will begin to see that it's actually economical to purchase those higher performance windows. Current codes don't recognize that, but when you start trying to really tackle the energy loss problem, that's what they find. And that's why I think we're going to see the value proposition of Windows change. Today, it's hard to sell people on Windows just on energy payback basis. But when they actually start becoming a cost-effective way of actually building a house, I think that's where we'll start seeing demand from the construction industry for these products in a way that we have not seen today.
Yeah, and I think the other thing, I mean, you've mentioned the cost issue several times, and so I think the other thing to do is to look at, can you tinker with the equation there? I was on a webinar the other day. There's a program up in Seattle trying to get deep retrofits in existing buildings. What they do is they calculate the potential savings from that deep retrofit, and these typically going to have long paybacks, and so as you're saying, they wouldn't normally be done. But then the utility will give you a 20-year loan, or payback 20-year loan. They'll calculate the savings, and they'll essentially, you're going to pay back the loan out of the savings, but the utility is fronting that money from you. So the utility fronts the capital cost of making the, say, window retrofit, and then they figure that saves you X dollars per month on your bill, and your bill is going to be lower, so they're able to sort of play some games there financially. And that program apparently is working out pretty well. The other comment I'd make is that Windows compete or try to compete with, a better heat pump or better lighting. Heat pumps and lighting and all that good stuff typically gets replaced every, 15, maybe for lighting, 10 to 15 years, for HVAC every 20 to 30 years. Windows typically, or should last, 30, 40, 50 years or more. So when you make a suboptimal decision today about a window, you're really stuck with it for a long time. And we've got all these programs out there to be carbon neutral by 2030, 2040, 2050. Well, the windows in your house that you put in your house today will probably be there in 2050. You may have a chance to change out the HVAC before then, but probably not the window, or not normally the window. So there's another argument to make a bigger investment in the envelope generally, because the envelope is there for a long time. And I'm hearing more and more of that. Whether it gets translated into actionable code items is sort of still remains to be seen, but the thinking is changing along those lines. And in case you haven't noticed, the politics have changed in the US a bit, or in the process of changing. So I think you're going to see a lot of activity, a lot more activity starting in January, thinking about these kinds of issues at a national scale. There's been quite a bit at the state level, but it's now going to sort of rise up to the national level as well.
So Dave precised his thoughts. I don't know if you saw.
Yeah. So back to the earlier question where Dave was saying that what we were discussing, he was referring to size-based U values.
Okay.
So there was a discussion on the size-based U values at the Windows experts team. That possibly also, I'm not sure if that discussion included. Another discussion, a similar discussion, was raised, I think, at one of our technical committees. One of the problems with the NFRC method of reporting window thermal performance data is that it's based on the standard size, and it doesn't give you the frame U values and the edge values that would be helpful, that would allow anyone to calculate actual size values. And what's interesting to me is that the European methods for evaluating heat loss through windows are actually designed to help you evaluate the actual size performance, because they give you a frame value, an edge of glass value, and a center of glass value. And now anyone can determine an actual size window U value. And frankly, that's something I'd like to see implemented at the CSA A440 or even NFRC, because if those values could be part of the standard output, they're there. Like, the values exist. It's just that they're not reported. And if they were reported, it would just allow architects, designers, anyone that wanted to get a handle on actual size window performance to do some pretty simple calcs to realize what the differences are.
Yeah, I think that discussion, I've lost track a little bit of the details of NFRC, but I think that's underway. They're looking, I mean, they had a component-based approach which could deal with size easily on the commercial side. That didn't go very far, but I think they're looking at that now on the residential side. And as you say, the important point is that all this stuff is calculated in the window therm programs, and all the data exists. It's just a question of whether it's exposed and accessible. So it would be a relatively, from a technical point of view, relatively simple change to make that happen. It makes life a little more complicated. I mean, the passive house folks have argued for that for a long time. They also require things like that. So yeah, I would think that would be a change that could be made. I wouldn't force everyone to do that because it's going to be a bit more complicated, but I'd allow it as an option to kind of fine tune performance for those who want to sort of put the extra time and energy.
That was our idea, was just to make that data reportable. Not mandatory reporting, but that it would exist in the simulation reports. It would exist in the official certified data, so that those who needed access to that information could get it from a trusted source. You know, that the certified data output would include those values, which could then be used to make the data more valuable when you actually start doing sharp pencil designs.
So I think that the issue here is, of course, that the market needs to make that demand, if you will, needs to be vocal about that and let those organizations, CSA and NFRC and others, know that it's important and useful, and presumably those changes can be made.
We've had, we don't have questions from our callers, but I'll bring up another subject. I've had window manufacturers ask me, why can't we have a way of reporting actual size values? And where this comes up is under the British Columbia Step Code, Energy Step Code, when you're designing to higher levels of that code, you've got to do that performance model for each home. And so we have the people doing the simulations. They're called energy advisors. And they're saying, we need a U value of this much for the window. And of course, all you have is your NFRC value. And they say, well, you don't have a product that'll meet my need. But, the manufacturer says, no, but look, all your windows are larger than the NFRC size. My windows at the NFRC size will be at the value you need. Trust me, put my numbers into your software and you'll find out. But it's hard to get that point across, because some people think that the U value is a fixed value. They don't understand that it scales with size. And so, I've had manufacturers who are working in BC asking that, like, why can't isn't there a way we can give them actual size numbers? And it's out of that conversation that the idea of, we can do what the passive house people do: frame U value, edge value, glass value, and you can do a fairly quick calculation that shows the impact of size and really the disproportionate influence of framing versus glass in terms of the performance. So,
and there's certainly opportunity to improve frames and edges and all that as well. But the first step ought to be just to make it easier to get size-based numbers out of the system, as you say. So that's something that it seems to me wouldn't take a huge amount of effort to actually make it happen, but it would take some effort. So
we'll find out soon. We'll find out when we try it. So we have one more question here. David is asking this question: based upon that U.S. climate zone map shown in the presentation, in which climate zones would triple pane performance be optimal now or established for future code compliance?
Yeah, so since this is basically a U value improvement, it's going to be scaled to the coldest climate. So it's going to be the northern, if you think about in the US, the Energy Star, the northern zone or the climate zones up on the north there. What was interesting is that when California did its modeling for its new code, these thin triples came out looking quite good in all climates across California, including the sort of central hot areas. There were two reasons for that. One is because when you get into the Central Valley in California, when it's 40 degrees C all day long, or even into the night for months in the summer, then the delta T part of it, which is what the U value helps you with in the summer, actually is some modest help as well. But quite frankly, what also typically happens is when you're using these double coating packages, is that the SHGC, the solar heat gain coefficient, goes down a little bit. And so the combination of improvements in the U value and the solar gain compared to the prior code compliant value, you end up with a product that performs better, that saves more energy. So we were pleasantly surprised to see the improvement across essentially all climates in California. Now, the size of the improvement varied in the mountains in the eastern part of the state, the coldest part. The savings and the payback were fastest. In the Bay Area where I live here, like in Oakland area, there's a little bit of chill in the winter and it helps there too. It was the kind of the mild places where in theory you can live in a house without heating or cooling, that it's not as much of an issue. I should mention that my gas furnace died three days ago, and got a couple of small portable room heaters here that keep me warm, but I'll survive fine until I get that fixed. So it's not an extraordinary, I live in the Oakland, Berkeley area, not an extraordinarily difficult climate, but it was useful to see that there are a bunch of reports out. If people are interested, I could dig up some reports on the savings. And like you were saying, that California has this point system. So going to a triple gives you 1.6, what are they called, EDU points or something like that. And that's equivalent to the wall insulation package and other stuff. So you can do this fairly simple trade-off. It's climate zone based, but fairly simple trade-off of how the windows stack up against a better furnace or more insulation in the attic and all that. Makes it pretty easy to do.
Well, that looks like it's all the questions that we have for our presentation today, but Steve, we're so happy that you could join us today. This has been the most, well, it's really the first presentation on thin triples that I've been aware of in Canada. So we're happy to get this update from you. Just back to California. So is there more of an attempt to commercialize thin triples at this point in California? Or you mentioned earlier, we talked about a pilot program that probably started a year or two ago with several manufacturers in the States testing out the thin triple concept in the marketplace, just to sort of feel it, feel out what the potential is. But it sounds like what California is doing now is creating a new market for this kind of a product.
Yeah.
Can you tell me what can you tell us about what's happening there in terms of that?
Yeah, that's a great question, and it's a little bit complicated. So what happened was, I got to get my timing right here. In the tail end of 2019, the California code folks saw that this looked like a good alternative option for the wall insulation package, and they wanted to push it forward. And so they were able to find some funds from their utility programs to get a couple of early demonstrations going that were going to be, that started towards the end of 2019. And that was that brochure that I showed before was based on that. Once the 2019 code hit, which was January 1st of this year, then that new wall package, and the reason they did that was because they saw that this new wall package requirement was coming, that the thin triple, or frankly any triple, was a good alternative to the wall package, and they wanted to help stimulate the market and get things moving. Now, so there was this plan of sort of launching a few demos at the end of 2019, and then as the 2019 code rolled out at the beginning of 2020, push it in a bigger way. Something called COVID happened in the middle of all that, right? Which changed a lot of stuff. But in the meantime, a couple of manufacturers did respond and do now offer products. You can go to the NFRC directory and find products from a couple of manufacturers. More are looking at it. It's still this chicken and egg. The builder's really interested. The builders are still looking at dollars. Can they meet the new code requirement by putting in a more efficient heat pump? And is the heat pump cheaper than the windows? So they're playing all those games. But there's certainly been rising activity. Then in parallel with California, we got the, this national demonstration program going. And then California R&D program is funding this California demonstration. And that's, as I said before, it's a 3-year program based on multifamily housing and based on retrofit, which is sort of interesting to look at different parts of the market. The code program, of course, is new construction residential, so that targets different parts. So it's been a little bit confused because of all the COVID stuff and because of the delays in construction. Some of the staff at window companies we work with were laid off or furloughed at various times. So it's been a little bit of a bumpy ride, but I think things are moving forward. On the supply side, there's been more interest generated by the suppliers, by the people that make spacers and the gas. Well, I should mention one thing, if people start to look into it, the price of krypton gas has gone up, unfortunately, from what it was when we started a year ago for a variety of market reasons, but we think that's going to be a solvable problem. And we're pitching DOE for a little bit of R&D funding to come up with a cheaper way to produce krypton gas or extract krypton gas from the atmosphere. So it's not, it's a challenge. And the biggest challenge, frankly, is getting all the pieces and parts aligned. And in particular, getting to the point, I think the crucial issue is getting to the point where the market demand and volume is large enough for a window company to spend the real time and money needed to do some at least modest redesign of their window, get it certified by whatever the appropriate codes are, put it into their literature, train their salespeople. This is not my world. This is your members' world. They know it far better than I do, but we recognize that there's a lot of work to be done there, and they're not going to do it if they don't see a demand. So we're trying to work across all those dimensions of the problem and move them forward equally, so that no one of them at any point becomes a kind of a bottleneck. And again, I think we're making progress, and I'm hopeful, frankly, as I mentioned before, that at a national level, as the U.S. recommits to Paris and as national DOE policy starts to reinforce what some of the leading states have been doing, that we'll see more activity there. There'll be a couple years, I think, frankly, of demonstrations and prototypes and feedback and lessons learned and all that. And that Partnership for Advanced Windows is specifically designed to help on any side of that. We recognize that it won't be entirely smooth sailing. And if people are willing to share information and what works and what doesn't and all that, we think it'll move forward faster. But if you look at the long run, if you look at your 2030 goals, your aspirational goals there, to come anywhere close to that, you're going to need some new options. And we think this is one of multiple options that should be available. Well, super. Thank you very much, Steve. Sorry, I should just also mention that we published a bunch of reports, and I could, make a short list for you. I could get you a short list. I don't know how you handle information outreach. I mean, people can contact me directly, but I can give you. These are all reports that are available to download and give you a little bit more of an update on what's going on. Cover some of the material that I talked about today. And if you want to get into the details, contact me directly as well. Yeah, please do. Please do. Send those to us. You can send me by email, and we'll try to find a way to make that information, try to connect it to the, to the video, or provide it to our members in another way. So great, sure, I'll do that. Good. Well, thank you so much for being a guest with us on Tech Talks today. It's been a pleasure to meet you on the air, to have a chance to interact with you and to learn more about this subject. And on behalf of Fenestration Canada members, thank you for filling us in on these developments stateside that may actually turn out to be beneficial to us as well on our journey on the market transformation roadmap. Thanks, and I hope that by working north of the border and south of the border, we'll make the whole thing move faster and better and smoother. Sounds great. Thank you very much, Steve. Right on. Bye-bye. Great.
Awesome. Thanks, everyone. See you next year.
See you next year.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.